Assalamualaikum warahmatullahi wabarakatuh. So my name is Azan Shah bin Azli. So I will explain about the introduction of the eigenvalues and eigenvector. So the A need to be an n times n matrix. It can be 2 times 2 matrix or 3 times 3 matrix or whatever. So the scalar lambda is called an eigenvalue of A. So this is the formula for the eigenvalues and eigenvectors. So it is A times x equal to lambda times x. So the scalar lambda is called an eigenvalue of A corresponding to the eigenvector x. Okay, so this is an example for the eigenvalue and eigenvector question. So it is show that x is 1 and 2 and is an eigenvector of A. So this is the matrix 2 times 2 matrix. So you need to find the corresponding eigenvalue. So by the formula A times x, so you put the matrix 2 times 2 matrix like this and times by the eigenvector. So this is how you do it. 3 times 1 and plus 0 times 2, x times 1 and plus negative 1 times 2. So after you solve the matrix, you get this solution 3 and 6. So with this you can factorize it. So it will be like this, and 3 will times by matrix 1 and 2. So this will be the solution 3x. The x is the eigenvector, therefore the corresponding eigenvalue is 3. So that's for the example. So the definition for the eigenvalues is the eigenvalues of n times n matrix A are the n zeros of the polynomial this formula, or equivalently the n roots of the number of n degree polynomial equation and this equation. So that's all for me. Thank you.
Okay, let's continue for example 7.18. So the question is, determine the eigenvalue and eigenvector for the matrix A, which is 1, 1, 2, 0, 2, 2, negative 1, 1, 3. So first thing first, we have to find the eigenvalue for this matrix. So we should use this equation. Lambda multiplied by identity minus A equal to 0. So as we know, identity for 3 times 3 matrix is 1, 0, 0, 0, 1, 0 and 0, 0, 1. So multiply by the lambda, we'll get this. Lambda 0, 0, 0 lambda 0, 0, 0 lambda minus A, which is this, we will get this. Lambda minus 1, negative 1, negative 2, 0, lambda minus 2, negative 2, 1, negative 1, lambda minus 3 equal to 0. Next, we should find the determinant for this matrix. Then from this, I get this. And then I simplify back. We will get this. And then from here we can see that 2 plus 2 minus 4 we will get 0. So we can eliminate this, and negative lambda 2 plus positive lambda 2 we will also get 0. So we can eliminate this and we will get this. From here we know that lambda is equal to 1, 2, 3. So this is the eigenvalue for matrix A. To find the eigenvector, we use this equation. Lambda I minus A times x equal to 0. So we substitute 1 into the lambda here, and we will get this 0, negative 1, negative 2, 0, negative 1, negative 2, 1, negative 1, negative 2. Next, we want to make this matrix to become REM by using Gauss elimination. So by using the ERO, the first step is we change row 3 and row 1, we will get this. And then row 1 minus row 2 and row 3 minus row 2, and we will get this. And the final step is we multiply -1 times row 2 and we will get this. From here we can see that the rank of A is equal to 2, rank of AB also is equal to 2, and variable is 3. So rank of A is same with rank of AB but less than the number of variable. This means the system has many solutions. For many solution case, we should find the free rider. So from this matrix, we should name the leading one as group leader. So here also is a group leader, and from this we know that 2 is free rider. So for the free rider, we know that free rider at x3, so we let x3 equal to k, and then we take this row. So x2 plus 2x3 equal to 0. So we substitute this to k, and we get x2 equal to negative 2k, and x1 we already know it's 0. So from that we write back like this, and then we bring this k out by factorize, and then we will get 0, negative 2, 1. So from here we already know the eigenvalue are 0, negative 2, 1. So that's all from me. Thank you.
Hi, my name is Muhammad Idaham, and right now I will going to show you guys how to find the eigenvectors of a matrix. Firstly, we need to know the formula, that is lambda I minus A times x equal to 0. This question asks us about to find matrix A when lambda is equal to 2. Firstly, we need to find the lambda I minus A. In this question, we get matrix 1, negative 1, negative 2, 0, 0, negative 2, 1, negative 1, negative 1. After that, substitute the matrix that we get with the formula. After we substitute with the formula, we need to find the REM of the matrix. So we can use the method of ERO. After we get the REM of the matrix, we need to determine the rank of matrix, then the rank of matrix with B and number of variable. In this question, we get the rank of the matrix is 2, the rank of A with B is 2, and the number of variable is 3. This shows us that the system has many solutions. After that, we will let x2 is equal to k, because x2 column doesn't have 1 in it. With the equation in the row 2 of matrix, we find that x3 is equal to 0. After that, substitute the value that we get, that is x2 is equal to k, x3 is equal to 0 in the equation in row 1. So we get x1 is equal to k. At the end, we will get the eigenvector, that is 1, 1, 0.
Hi, Assalamualaikum warahmatullahi wabarakatuh, and my name is Nur Amira Shafika. I'm going to continue with this question, but my part is when lambda is equal to 3. Okay, as we know that this is the basic one before we start our finding eigenvalues and eigenvector. So we call it as characteristic equation. Okay, based on our question, the lambda is equal to 3. So we have to substitute this lambda equal to 3. So this is the new characteristic equations. So after we substitute the lambda with 3, we have to do the normal subtraction. Hence, we got a new metric, which is negative 2, 1, 2, 0,
negative 1, 2, negative 1.
1, 0. So we don't have to forget about the x1, x2, and x3. It is equal to 0, 0, and 0. Therefore, from this metric, if we do the multiplications, we can get the new equation, which is 2x1
Plus x2 plus 2x3 equal to 0. x2 plus 2x3 equal to 0. Negative x1 plus x2.
Okay, from all of this equation, we have to find something to substitute and solve it. So the first thing first, we have to substitute with constant. Okay, so from this equation, we can see that E2 is the simplest one to substitute with the constant. So with the constant k, we substitute it as x2. From that, we can get x1 equal to x2, which is k from this. Okay, and also from this equation, we have to find x3. We also have to substitute k into another equation that has x2. Like we take this in our new equation to find x3 with the substitution of x2, which is 2x3 equal to x2, x3 equals to 1 over 2 x2, and we substitute it with k, hence it will be like 1 over 2 k. So from all of this equation, we can get x1 as k, x2 as k, and x3 as 1 over 2 k. So in our metric form, it will be like k, 1 over 2 k, because it is x1, x2, and x3. So from this equation, we can factorize it and put the k out of the metric form. It will be like 2, 2, 1, because 1 over 2 is 1. So this is it. So in conclusion, the corresponding eigenvector is 2, 2, and 1. This is the correct way. Thank you so much.